Here we have a line that goes downward to the right, got a negative slope, and we're going to see whether the point 3, 6 is actually a point on this line. I have the equation for this line, and this 8 is not a coincidence that it's showing on the y-intercept. We'll see that later. But for now, I want to test to see whether the point 3, 6 is on the line. What you need to remember is that the equation of a line describes every single point that could be on this line. In other words, every point that we could think of will have to satisfy this solution, has to fit into this equation. So let's test this 3, 6 and see if it works. If I plug in x equals 3 and y equals 6, I'm supposed to get a true statement. Actually, I shouldn't really put the equals here yet. I'll put a question mark there. Is 6 really equal to? Well, 2/3 times 3 is going to be -2, right? The 3's cancel. And that really is going to be a true statement. 6 equals 6. So that means that the point 3, 6 is in fact on this line. Let's try the same kind of test for a point around here. I think this point is actually going to be something like 9, 3. Looks about right. Well, let's test it out to see. X, y is 3 equal to -2/3 times 9 plus 8. Well, that's going to be 3. This cancels with the 3. I'm going to give me -6 plus 8. Is 3 equal to -6 plus 8? No, that's false. So that means not on the line. Remember, every point should satisfy the conditions. And in fact, if you think about this for a little bit, test the numbers, you're going to realize that this number probably should have been a 2. So 9, 2 would be on this line. Think about that for a little bit. You can test it out. Now, this doesn't tell us every single point on the line, but you can actually find a point by plugging in, and it doesn't always work nicely. I'm going to take a value that will work with that fraction, 6, something. And try and calculate what the point would have to be if x equals 6, what would the y value have to be for this to be on the line.